All right, in this section, we're going to talk about consumer loans. This is, you'll be able to determine the payments on various loans you have, like for a car or for a house or anything like that. Let me put up the horrible looking formula. It's too hard to derive. Well, it's not too hard to derive, but it's not pleasant to derive, and I don't think the steps that I use will be very helpful in deriving it. So I'm just going to put the formula down. And let me put down what each of the letters is. The letter P in this instance is for payment. Most definitely, or almost definitely, that payment will be monthly. A is the loan amount. R is the APR as normal. As usual, N is the number of times that the loan is compounded, or the interest on the loan is compounded per year. And for most of our examples, practically every one of our examples, N will be equal to 12, since we'll usually be talking about monthly payments. And the letter T, as usual, is the time in years. So I'm going to spend a lot of time doing some examples to show how this formula works, and to show you how to plug it into your calculator, because it's a pretty brutal formula. So let's start off with an example. Suppose you buy a car for $16,500. The loan is for 60 months. At an APR of 4.1%. What are the monthly payments? And so let's put in the numbers that we know. We know the letter A because that's the loan amount, that's $16,500. R, the APR, is 0.041. N will be 12, we are paying monthly. T, 60 months is equal to 5 years. With car loans, they typically list them in terms of months instead of years for some reason. But I have everything there that I think, and then I need to figure out the payment. So let me put the formula down. P equals A times 1 plus R over N to the NT. Notice that that part is very similar to our compound interest formula. In fact, it's identical to it. And as you should imagine, the compound interest formula is built into this. Here we have 1 plus R over N, that quantity NT repeated, and then we have minus 1. So let's put in the numbers that we know. The A is 16,500. R was 0.041. N is 12. T is 5. Notice that up there, that's 60. And we knew that already, that it was going to be 60 months. So I could have bypassed the NT calculation, I suppose, and simply put a 60 up there. Now I have another R over N, 0.041 over 12. And all of that is divided by 1 plus 0.041 over 12 to the 12 times 5 minus 1. Let me simplify those exponents just to make this a little bit easier on us. So 12 times 5 was 60. Now, virtually all the calculators that people choose to use in my class have the same kind of display. So I'm going to try to enter this into the TI calculator. And if you follow exactly what I do, it shouldn't be a problem. Let's go ahead and pull it up. And let me see. The way we're going to want to write it, before I do this, let me come here and show you the way that we're going to have to write it. I'm going to have the numerator, which I can do in one line very simply. And in fact, because it's such a long formula, I'm going to put my P way over here. And then I'll have my 16,500 times 1 plus 0.041 over 12. And then you'll have, actually, and I wanted to indicate that I was going to write it the way your calculator would need to see it. So let me redo that. I have a 0.041 division slash 12. And then you may or may not have this little caret thing, 60. But after that, you'll need to put a times symbol. And I prefer you put it in parentheses, although I don't think it is required, 0.041 slash 12. All of that is the numerator. Now we do a slash for the denominator. Same, it's going to look the same on the screen, but I put the slash to show you how major it is. Now we're going to have to put the entire denominator in parentheses. So I know I'm making it look big because I keep forgetting I have to do this on a calculator. 1 plus 0.041 slash 12, 60 minus 1. That's the denominator. I need to encase that in parentheses, like so. So this is exactly how I'm going to try to enter it into the calculator. Some calculators will allow this 60 to be shifted up. Some of them you have to write this little caret. It just depends. All right, let me pull up the calculator and try to enter this exactly the way I see it. So we'll start with the 16,500. Now let me start the parenthesis. 1 plus 0.041 divided by 12. Finish that parenthesis. Do the exponent. Put a 60. Now on the calculator I'm using, the 60 is raised up. To come down off of there, I have to hit the right arrow. And I've done that. Now let me put the 0.041 over 12. Let me put a star first, or a multiplication sign, and then in parentheses, I have 0.041 divided by 12. Let me finish that parenthesis. Division, now we're starting the denominator, and notice the denominator starts with two parentheses beginning. Now we'll do 1 plus 0.041 divided by 12. Finish that parenthesis. Now raise that to the 60th power. Bring it down. Minus 1. Finish the parenthesis of the denominator, and let's see what we get. I get about 304.62. So yeah, this is roughly equal to 304.62. So your payments are $304.62 every month. Suppose the previous loan was for only 48 months. What are the payments now? So in this situation here, everything is the same except for the length of time. So the amount is still going to be $16,500. The payment, I don't know that. R is still 0.041. N is still going to be 12. And T, since we're talking about 48 months, that's 4. So 4 years. So when we do my formula, I have P equals A times 1 plus, I'm going to write it in calculator friendly format. And I've noticed a few places where I have not filled in the numbers. So actually, you know what I decided to do? I think as I was writing it in the middle of it, I decided to leave just the formula in this format. And now right below it, I'll go ahead and put my numbers in. So this hopefully is a calculator friendly format. Let me separate that. So I have my 16,500. I have 1 plus, if you want to save some space on your screen, I guess you can do 0.041 divided by 12. I never thought about the space saving capabilities of doing that. And now it's to 48 months instead of 60. Remember, that is 4 times 12 up there. Then we have 0.041 divided by 12 slash double parenthesis 1 plus 0.041 divided by 12 to the 48 minus 1 and end that parenthesis. So let me go ahead and throw that into the calculator. Now for these, I usually like to clear out my screen just because there's so much going on. I'm going to have to move the calculator around to get it all in there. So let's start with my 16,500. Now let's start a parenthesis. Here I'm going to have 1 plus 0.041 divided by 12. Finish that parenthesis and take it to the 48th power. Come down from there, put a times. I'm not certain this times is necessary, but I'm being careful. 0.041 divided by 12. Finish that off. Start the division bar, I guess. Go to 2 parentheses. Let me move this out of the way. 2 parentheses. Start 2 of them. Then we have 1 plus 0.041 divided by 12. End that little parenthesis. Take it to the 48th power. Come down off of there. Minus 1. Finish the denominator parenthesis. Enter. Oh, I made a mistake. This happens on my calculator sometimes when I put in a minus instead of, or I use the keyboard. It causes some issues here. I need to put in just a minus sign. My keyboard doesn't do the minuses. So then we'll go ahead and delete that. That was not a big deal. This is minus 1 instead of times -1. That's the way it was reading it. Let's do it again. And I get 373.29. Those mistakes that I'm making in the calculator, you will not make because I'm trying to use my keyboard because it's so much faster than the on-screen keyboard, but not all the keys on the keyboard match the keys in the calculator, so some strange things happen sometimes. Anyways, our monthly payment then will be $373.29. Suppose You buy a home for $100,000 at 2.9% APR. If the loan is for 30 years, what are your payments? So let's get our information in. We have A is 100,000. P, we're trying to figure that out. R is 0.029. N is 12. T equals 30. So our payment looks like the following. So we have our $100,000. 1 plus 0.029 over 12 to the 12 times 30. 0.029 over 12 1 plus 0.029 over 12 to the 12 times 30 minus 1. Once again, you want to probably put in to your calculator what will probably work. I'm going to start doing these on the keyboard itself, or on this version of the calculator so that you can see. Let me clear everything out. Most of your calculators work like this, so I believe it will be fine. So here's how I start it. 100,000. And then I'll start my parenthesis. I'm working the numerator right now. 1 plus 0.029 divided by 12. Finish that parenthesis, and now start an exponent. And 12 times 30 is 360. You can save yourself some grief just by putting that in. Now, some calculators will have a raised exponent like I do. See how it's up there? I have to hit the right arrow to bring it back down. And now in parentheses, I'll put the 0.029 over 12. Finish that parenthesis. And a division bar. Now I'm ready to start the denominator. Now make sure you encase the denominator in parentheses. And you notice if that's true, then I'll have a parenthesis around the left and a parenthesis around the right. If you can sort of get your mind to think about that, I will then have this quantity inside of those parentheses. So I'll start a second parenthesis. I'll do 1 plus 0.029 divided by 12. And I will raise it to the 360 power. Bring it down out of that exponent if you have to. Subtract 1. Finish the parenthesis in the denominator and hit enter. And to 2 decimal places I get 416.23. So our monthly payments are $416.23. Now, suppose you buy the same home as in the previous example, except your loan is only for 15 years. Same interest rate, everything. So now, how much are your payments? So let's get our numbers down again. The A is still 100,000. The P, I don't know that. The R is still 0.029. N is essentially 12 unless I say otherwise. And then T this time is only 15. So our formula then, P equals A times 1 plus R over N to the NT times R over N divided by 1 plus R over N to the NT minus 1. Now let's go ahead and put our numbers in. I've got my 100,000 times 1 plus 0.029 divided by 12 to the 12 times 15. By the way, 12 times 15 is 180. I'll make use of that in the next step. 0.029 over 12. And then we are going to divide by 1 plus 0.029 divided by 12 to the 12 times 15 minus 1. And let's go ahead and get 2 decimal places on that. Now, a beautiful thing about these calculators is the following. Once you get one of these things to work, I can hit the up arrow and it will let me click on it and bring it back down. This works on the other TI calculators as well. You don't have to go and type it in every time. So now all I have to do is go up to the exponent and change them to 180. So just delete that out of there and put in 180. That's the only change I have to make in the whole problem is in the denominator and in the numerator on those exponents. There's only one other place where there's a 360 that I can fix. So delete, delete. I actually don't think you have to delete. I think you just overwrite it with 180. And now let's look at the hit enter. This time I get 685.78. So now the monthly payments are $685.78. This is something I want you to notice before I go on. Notice that the amount that you're paying is not double. Even though you're paying it off in half the time, your payments are not double. That's all tied into compounding, and its behavior is logarithmic, which means it doesn't operate the way that you're used to things operating. So if you look, let me come back. The original for 30 years was $416 a month. If instead you decide to pay it off in 15 years, you don't pay $800 some a month. You pay $260 more a month, which is not quite double, and you pay it off in only 15 years instead of 30. There's also a little bit more. In these 2 previous examples, look at the total amount that you paid for the house. So in the previous 2 examples, we paid off a house in 30 years and then in 15 years to make a comparison. So let me put this down. For the 30-year loan, our payments were $416.23. For the 15-year loan, we have $685.78. Now let's take a look and see how much you actually paid for the house. So in the 30-year loan, the total of all payments was equal to, you had 360 payments and each payment was $416.23. Now for the other loan, the total of all payments equals, this time you only had 180 payments, 15 years, times, well, how much do we pay? $685.78. Let me get the totals on these. So I'll bring up my calculator and we'll start with the first one. See if I can get myself enough room. There we had 360 times 416.23. And I get 149,842.8. 149,842.8, which means it's really 0.80. So on a $100,000 home, for 30 years, you ended up paying close to $50,000 in interest. Anything over $100,000 you've paid in interest. And there's probably fees and things like that that would make that even worse. Now, let's look at the 180 payments and compare how much you actually paid for the house there. So I take my 180 payments and I multiply it by 685.78. This time I get 123,440.4. So this time, in paying it off in 15 years, you've paid $23,440 in interest, whereas before you paid $49,000. So by paying it off in 15 years, you saved somewhere over $26,000 doing that. Of course, the shorter term you pick, the higher the monthly pay or the monthly cost will be. The monthly payment will be higher, but it won't be as higher as the amount by which you shorten the length of the loan. So the shortest length that you can get is always going to be the most beneficial for you from a cost standpoint. Not only that, it's quite typical for one interest rate to be offered for 30 years and then a lower interest rate to be offered for 15 years. So you even do better than what I have on this example. A car dealership offers two options on a $25,000 car. The first option is 3.5% APR, 60 months, $1,000 cash back. The second option, 2% APR, 48 months. No cashback option on this one. Now, you should understand when they say cashback option, there's a number of ways you can do it, but almost certainly the way you're going to work a cashback option is you're going to take and buy the car for $25,000. Before you make a single payment, they're going to take $1,000 off of the price of the car. So you're really going to take out a loan for $24,000 in the first case. So that is, I mean, I guess you could still do a loan for $25,000 and just ask them to hand you $1,000, and I think they'll do that if you want. But almost everybody always takes the $1,000 off on the price of the car. So in situation 1, our A is not $25,000 but $24,000. Our payments, of course, I don't know what that's going to be. The N, of course, is 12. R is 0.035. And then T, since it is 60 months, that is 5 years. And let's put our formula in. P equals A times 1 plus R over N to the NT times R over N divided by 1 plus R over N to the NT minus 1. And, well, let me give myself some more space when I put in the numbers. So I'll have my 24,000 for my A, at 1 plus 0.035 over 12 to the 12 times 5, 0.035 over 12. And then for the denominator, I get 1 plus 0.035 divided by 12 to the 12 times 5 minus 1. And let's go ahead and throw that in. Now, when you turn on your calculator, mine turns itself off. It's sort of annoying, but you can go way back up here and bring back down the calculation that you did before. And now 12 times 5 is 60. But I have a lot of things to fix as I go along. So I'm not going to start from the back to fix it. I'm going to start it from the front so that you can see it step by step. Of course, you always have the option of simply re-entering the entire formula every time, but I find that is kind of painful. So let me change mine to 24. Now right now I have 240,000, so let me take out a 0. And then let me adjust my numbers. So 0.029, this time I'll change the 29 to a 35. Let's see what else you have. Oh, there's an exponent there. This exponent of 12 times 5 is equal to 60. So let me come back here and make that into a 60. And I think there's an extra letter there, so let me delete that and then come down from the exponent. I think I'm going to be on this part of it now, so I got to change my 0.029 to a 35. Got that. Now I'm getting into the denominator. That will be a 35. We're talking about this number right here. That'll be a 35. Okay. And then the new exponent here, once again, will be a 60. And then there's an extra 0 that I can delete out of that. And I think I am done. Yeah, let's go ahead and hit enter. And I get 436.60. So this was $436.60. That's option 1. Those will be your payments. Now let's go ahead and take a look at option 2. This time, you didn't get any cash back, so the amount you'll be financing is $25,000. Payment, of course, I don't know. The N is still 12. However, this time, the rate is 0.02. And as I said before, notice how it's a shorter time period and you're getting a better interest rate. That is common. This time, since we're talking about 48 months, T is equal to 4 for 4 years. All right, let's put our numbers in. P, well, I'm not going to put it in yet because I like to put it down the formula and then I'll put in the numbers. So I have A times 1 plus R over N to the NT times R over N divided by 1 plus R over N to the NT minus 1. Let's get our numbers in. A is 25,000. 1 plus 0.02 over 12 to the 12 times 4. By the way, have you noticed that every time, this is the total number of payments in the exponent. There are a total of 48 payments. So if you just know the number of payments, you don't have to do that little calculation. Just put the total number up there. Anyways, the R over N is 0.02 over 12. And then we are going to divide this whole thing by 1 plus 0.02 over 12 to the 12 times 4 minus 1. And since I've decided to put my work over there on the left, I'm going to have to move this calculator to the right. And once again, I'll go up to my previous work and edit it. Now, it is annoying how it starts you at the end of the thing, but I personally, I don't like erasing and replacing in a backwards fashion like I am doing right now. Notice that that was just 0.02, so I have to actually delete a digit there. And now let me move to my numerator. Delete that thing. And then change that 3 to a 2. Keep moving to the left. We're going to change that to a 48. Keep moving to the left. Let me delete that 5 and change that 3 to a 2. Got it. And then finally, I think the last thing I need to do is change that 4 into a 5. Enter. 542.38. So there's our payments on that one. Now, of these two, which is the better deal? What exactly do I mean by the better deal? The better deal is the one that costs less overall. That's what we want. So let's grab our payments here. Let's see if I can get them both on the screen. $436.60. So in option 1, I had 60 payments. Each was $436.60. In option 2, we had 48 payments, and each one of them was $542.38. Let's go ahead and get these numbers. So I have my 60 times 436.6. So $26,196. So in this scenario, Remember, the car was financed for $24,000. So about $2,196 were in interest. Now on this other one, let's take a look at its total cost through all payments. So we'll have 48 times 542.38. And here I get 26034 point, not that this point matters much, but let me throw it in there, 24. So if you consider the better option to be the one that has the lower overall payments, this is the guy right here. In fact, if you think about it, in option number 2, we paid only $1,034.24 in interest. In option 1, since we were only financing $24,000, we actually had over $2,000 in interest. So you can see that option 2 was better. However, people will choose option 1 because to a lot of people, the monthly payment is the thing that they budget, and they might be able to make the $400 payments and just can't quite get the money together to handle $542 every month. One of the things you may be interested in, or one of the ways you can decrease your monthly payments, is to use something called a down payment. A down payment will decrease the loan amount. So as an example, in that previous example where you got $1,000 cash back, you only had to pay on $24,000, you can look at it or view it that you paid $1,000 as a down payment on the car. And that's exactly what it is. Down payment is how much money you're willing to put up front to decrease the loan and make the payments more manageable. Let me show you an example to explain how it works. Most banks, I wouldn't say most, but a lot of banks would like you to put down 20% of the value of a home before you purchase it. So as using that as an example, suppose you purchase a house for $200,000. At an APR of 5.1% for 15 years. If you put down 20%, what are your payments? 20% used to be the standard. I'm not exactly sure what it is. I think it's come down to 10, and I've heard of loans being as low as 5% or even 3% down. But for some reason, the banks have always required some amount of money down, I guess, to show that you are responsible enough to make such payments. But anyways, but in any case, let's go ahead and do the down payment first. So this was the 20%. So what you're going to do is take 20% of the amount of the loan. 20% of 200,000 equals $40,000. That means you will have saved up $40,000 one way or another so that you can give it to the bank before the loan even begins. So this is going to affect you. The amount that you're going to actually have to pay on then after this is actually only $160,000. because you've already taken 40,000 of it out of the equation. I don't know what my payment is. N, of course, is 12. R equals 0.051. And T equals 15. Let me get my formula in. I have A times 1 plus R over N to the NT times R over N all over 1 plus R over N to the NT minus 1. And now let me put my numbers in. So we're financing $160,000. 1 plus 0.051 divided by 12. 12 times 15. Remember, that's equal to 180. 0.051 divided by 12. And all of that is divided by 1 plus 0.051 over 12 to the 12 times 15 minus 1. All right, let's bring out the calculator. And don't forget, we don't have to enter this from scratch. Even though the calculator turned itself off, it still has that stuff in there. All I've got to do is mosey on up to I get to where I noticed the formula was, and I'll bring it back down. So 12 times 15 is 180, so I'm going to change those 48s to 180. And you can just overwrite what is there. Now, more cumbersome, though, is what happens when I get to 0.02. Unfortunately, if I try to overwrite it and put a 5-1, the 5 will replace the 2, but the 1 will erase the division. I don't want that. What I would like to do is put my 5 in, but now I don't want to overwrite that division bar because then I'm going to have to redo the whole thing, and I don't want that. So what I can do is go second above delete will allow me to insert a 1, and it moved the division out of the way. Now, I don't believe you're in insert mode once you continue on your way. So, I think I'm going to have to put a 5, and then I'm going to have to insert again to make sure. But notice that the cursor changes the way it looks. And there, I've got my 1 in place. Now I'll keep on moving along. Now, the exponent here, I know is going to be 180. And because my exponent is up like that, it'll overwrite and move the rest of the stuff out of the way for me. Now come down here. 0.02, once again, I got to change that to a 5-1. So let me insert my 1. Got it. And then this 25,000 is 160,000. So I'm going to have to enter a 0. I'm going to have to insert a 0 in there because I've only got 3. And there you see it. So it looks like 1273.62. Suppose you purchase a home for $150,000 at an APR of 6.5% for 30 years. What are your payments? Let's put our numbers in. A will be 150,000. P, I don't know that. N will be 12. R equals 0.065. T will equal 30. So once again, my formula, A times 1 plus R over N to the NT times R over N divided by 1 plus r over n to the nt minus 1. Now let's plug our numbers in. So I got my 150,000. There's my A. 1 plus 0.065 over 12 to the 12 times 30 times 0.065 over 12. And then all of that is going to be divided by 1 plus 0.065 over 12 to the 12 times 30 minus 1. And let's let our calculator run through it. I will, of course, bring up my previous work and work my way backwards. It looks like in the denominator I'm going to have to change the 180 to 360. So I can just change the 18 to 36 and it will overwrite it. The 0.051 I now want to be equal to 0.065, so I'll change my 5.1 to a 6.5. Moving on, change that 5.1 to a 6.5. Moving on, change that 180 to a 360. Got that. Change that 5.1 to a 6.5. And then change the it was 160,000 before. All I need to do is change that 6 into a 5. I get 948.10. So my monthly payments are $948.10. This brings up an interesting, or not an interesting thing, but a very financially important subject next, and that's the subject of refinancing. Refinancing is an attempt to make your loan easier to pay, or in other words, to make your loan payments smaller. So the way it works is this. You have a loan that you've been paying for a while, and you decide that the loan payments are too much. Some sort of a bank that you've seen advertising a lower interest rate, you've decided to go and apply for a loan from them. Although you tell them that it's a refinance loan, that makes a difference. So they look at your old loan. First, they'll look to see if you're making your payments regularly. And then if you are, chances are they'll be like, oh, we'll probably accept you for a new loan at a lower interest rate. Then what they'll do, if they accept you for the new loan, they give you enough money to pay off your old loan at the old rate. And then from now on, you'll pay on a new loan at a lower interest rate. Suppose you want to refinance the previous loan after 10 years. So you've made 10 years worth of payments on your house. You owe a certain amount of money. Okay, whatever you owe, you get a new loan to pay that off. So suppose you still owe we'll just say X dollars. Okay, you get a new loan for X dollars, but at a lower APR. You take your new loan and pay off the old loan. Additionally, You do not want to increase the number of payments that you make. Let me say it this way. You don't want to extend the length of the original loan. So what I want to do is refinance at a lower rate, but at the same time, I don't want to spend I don't want to spend more than 30 years total paying off the whole loan altogether. So I got the original loan for 30 years. I've been paying for 10 years. I get a new loan for a lower interest rate, but my new loan, I make sure that it only lasts 20 or fewer years. That way, I'm still done paying it off at the same time as I originally was, but now I've decreased my payments for the last 20 years. First thing you need to know, though, before you do it, is you have to know how much you owe on the loan, and that's another formula. So to do this, we first find out how much we still owe on the first loan. So we have a formula for that. Let me write it down. It's not pleasant either. None of these formulas are, but this is the way it looks. So the amount, I'll need to call it this way, owe. This is how much you owe. And it will equal A times 1 plus R over N. There that thing is again, to the end. Now look at what I'm going to do. I'll put two little lines up there for the T. I'm specifying a different look to my T. Then we have a fraction here. P times, here we're going to have 1 plus R over N to the NT minus 1. All that stuff is in parentheses, and this second piece is a fraction. In its denominator is R over N. And that T, once again, has two slices. The T, everything is the same as what you think it may be, except the T here equals the time that you've already paid. So in my example here, I've made 10 years of payments, so the T double bar is equal to 10. That's what I can do for my O then. So my O looks like this. The original loan was $150,000. So I have 1 plus, and it was at 0.065, it was at 6.5%. And we paid 12 payments a year, so 12 monthly payments, but we've been paying for 10 years. And then the amount of payments that we just figured out for that loan was $948.10. Then I'll have 1 plus 0.065 divided by 12 to the 12 times 10 minus 1, that ends that parenthesis. And then this fraction is just for the second piece. I'll have 0.065 slash 12. That is a long thing. Let's see if I can get it into the calculator. None of it's really hard to put in there, but it's very lengthy looking. Now this is completely different. Although I could probably take, like if I come up here to this and bring down like so. All right, now let me come back to what I had here. There was my 150,000 times all of that stuff. We paid 10 years on it, so I'm going to change the exponent to 120. And then I'm going to subtract, no, get out of there. You don't want to remember, to leave the exponent on this calculator, you've got to come down first. Then I'll start a subtraction.
and then let me enter the rest of the stuff, which is over here. So I have my 948.10, and then in parentheses, I see I start a double parenthesis so that I have that inside of there. Let me put the 1 plus 0.065 divided by 12. That thing, finish that parenthesis, take it to an exponent, put 120 up there, come down and put -1, finish that parenthesis. Now in this denominator, I like to encase this denominator in parentheses just to be on the safe side. So I'm going to put my r over n inside of parentheses. So I'll put 0.065 divided by 12, and I'll finish the parenthesis off down there. So we owe $127,000, a little more than $127,000. So that is how much we still owe on the home. So the way this works now is now you get a new interest rate and you're going to get a loan for exactly that amount. Now, it's not true that you have to get it for exactly that amount. You could probably, the bank will probably give you $130,000, or they may give you $120,000, whatever. And then you have a few extra, 100 or a few thousand extra to do something with. Now, suppose you are able to refinance the loan for 20 years at an APR of 3.3%. Now what are your monthly payments? So this time the amount of the loan is $127,164.53, exactly the amount that you owed. Payment, the new payment, I don't know what it is. N will of course be 12. The new R is 0.033, and the new T is equal to 20. So now let me put our numbers in. A times, well, the letters at least, R over N to the NT times R over N divided by 1 plus R over N to the NT minus 1. And so P equals 127,164.53 times 1 plus 0.033 divided by 12 to the 12 times 20 times 0.033 over 12. All of that divided by 1 plus 0.033 over 12 to the 12 times 20 minus 1. And let's have the calculator run this. Of course, I'm going to have to go up a few steps to find out where my previous stuff was. I don't think it was in the previous step, but I think it was up here. Let's see if that's true. It looks like it, yes. So now let me go ahead and change. 12 times 20 is only 240. So let me change my 36s to 24s. Let me change my 6.5 to a 33. Change that 6.5 to a 33. change that 360 up there to a 240. Change this 6.5 to a 3.3. And then finally, let me change the loan amount to $127,164. And I need to make room for my decimal, so I'm going to have to insert the 0.53. Not that that makes a huge difference in the payments, but nonetheless, I would like to get this very exact. 724.50. So you can save substantial amounts on the loan. Take a look at the payments here. You have, where is the old payment? The old payment was $948.10. So you went down by $224. So now for the last 20 years, you've got a lower payment to make on the house. And since you've already been used to making the payment, this will seem like a bonus. It will almost seem like now you have $200 extra. In fact, there's even more. The original loan had 360 payments of $948.10. If I take the total cost of owning through that loan, that would be 360 payments times 948.10. Let's see how much that would have been. So we have 360 times 948.1. So we get 341,316. So notice the original loan was for $150,000. In this scenario, you've paid, when all is said and done, you would have paid almost $200,000 in interest. Now for the new loan. Has 240 payments of $724.50. So what is the total cost of this one? Well, this one, don't forget, you already paid 120 payments at 948.10. Now for the next 240 payments, you're going to be paying $724.50. Let's see what this turns out to be. So let me grab this again from up here. I'm going to change that 360 to a 120. And then I am going to put in the rest of it. So for the rest I had plus 240 times 724.50. Here we've got 287,652. So now you ended up paying $137,000 in interest on the loan, which is a good $54,000 less than what you had originally done. So you can see these make big differences. A typical thing that people will do is when they get a loan a new loan like this, when they refinance and they're able to save some extra money, they may start an extra fund, say like a college fund or a retirement fund that is totally separate of anything else they're doing, because now they have some bonus money that they can put to use.